Okay, so we just went over how to measure voltage and current. So let me give you a decent problem. Okay, let me give you a decent problem. So let's just say I have some battery that is 24 volts. Some battery or a power source, 24 volts. And then, I know, beautiful, a work of art. I'm truly an artiste. Okay, let's make this 3 ohms. Let's make this 5 ohms. Why not 4 ohms? Okay, so if I have 24 volts up here, now let us think about one thing. Is that how many pathways are there? It should be quite obvious. There's only one. There's only one way to go if you're an electron or if you're a charge moving through the circuit. There's only one way to go. There's not multiple routes that you can take. Just you start here and boom, you end here. And you have to go through these obstacles. But remember, I told you that this is my potential and it has to be used up throughout the circuit. So let me write this equation out for you to help you understand equivalent resistance. So V total, which is 24, is going to equal, let's say this is R1, R1, R2, and then R3. So this resistor has resistance. It also has a current through it, flowing through it, and it also has a voltage before and after, or across it, okay? So this R1 can relate to V1. So again, just like dropping something off of a cliff, it's going to have to use all of its potential to reach the end right here. So starting from here, reaching here, each drop, this is going to be like a stair down, another stair down, and another stair down. So all these stairs added together equal the total height of the staircase. So V1, V2 plus V3. So the voltage here from the beginning to the end is going to be equal to the drop in every single resistor in this circuit that's in series. So remember the equation V equals IR. Let's just plug that in. So V tot equals I1 R1 plus I2 R2 plus I3 R3. However, since there's only one way to go, the current here is going to be the same as the current here, current here, current here, and current right here. Because there's so many electrons, they're all kind of constantly bumping into each other. So then I can replace all of these I's with just I1, I2, or I3, or I in general. So I'm going to say V total is equal to I R1 plus I R2 plus I R3. Since the current is the same everywhere, do you see something that I see? Let's take that out. V total equals I then times R1 plus R2 plus R3. Now in this situation, you can see that V total is equal to I times the equivalent resistance. And you see, if I have 3 resistors, the equivalent resistance is going to equal to R1 plus R2 plus R3. Now the main idea that you need to know is that if I have anything in series, I can just add up the resistors like I would with adding anything, right? Apples, oranges, ice creams, things like that. So if it's in series, if there's only one way to go, to find the equivalent resistance of all of these put together, I can just add them up. 3 plus 5, 8 plus 4, 12. So the equivalent resistance here is going to be 12 ohms, which is 3 plus 5. Oh, don't forget the ohms. Ohms plus 4 ohms. So that is the equivalent resistance of this circuit. So if I give you another one with any numbers, you just have to physically, okay, 1, 2, 3, add them all up. It doesn't matter what they are. If they're in series, that's the answer. Now the other thing that's important is actually knowing this part, is that current is the same. Current stays the same in series. Okay, remember that. Current stays the same in series, and then the equivalent resistance of series, you just add up together like that. Hopefully that makes sense. I'll add some more problems for you to do. Good luck.